Hello students and welcome to the lesson on sinusoids. Now in the previous lesson we've sort of graphed this picture already by taking a ruler and measuring the vertical distance here because this is the sine function and then transferring those distances along here. So if you don't know where this picture comes from or you don't have this picture drawn yet, you need to go back and look at one of the other videos, one of the earlier videos. Okay? And just to reiterate here that this is the sine function right here. This is f of theta equals sine of theta, and that's what I have graphed right here. So what we were doing is we were graphing theta along the horizontal axis, and we were graphing y, it's this y right here from the unit circle, or sine of theta along the vertical axis. And once we graph it and we sort of connected all of these dots, we can see that it forms a wave. Okay? And if you look back to your handout on one of the 12 basic functions, this is the picture for the sine function. And so this is a unique type of function because it has some very special characteristics. But now before I get into all of that, I want to label all of this in radian because radian is how we are going to work primarily. Okay? So this is 0 degrees, so that's 0 radian. This is 90 degrees, so this is pi over 2 radian. This is 180 degrees, so that's pi. Okay, I'm going to label all of these. 270 degrees, so that's 3 pi over 2. 360 degrees, that's 2 pi. 450 degrees right here, so that is 2.5 pi, or 5 pi over 2. Okay. I'm also going to go into the negative side here, and this is going to be negative pi over 2, and this is going to be negative pi. Okay. And as we look at this function, there are some special characteristics that certainly come up. And one of the first characteristic is that it repeats itself. If you look at the graph, let's say we started at 0 here, it goes up, it hits 0 again, and then it goes down, and then hits 0 again. And then after that, it's going to go up, hit 0, go down, hit 0 again. Okay, so you can see that this wave repeats itself over and over again. And we want to figure out how long does it take for the wave to repeat itself. So we can take a quick snapshot here from 0 to 2 pi. Okay? This length here is 2 pi. So we can say that this wave repeats every 2 pi units or 2 pi radian. And I went from the starting point here to this starting point. Another way you could do it is go from the max values to the other max value, and that will also help you see that it repeats. So it reaches a maximum at pi over 2, goes down to the minimum, goes back up, and reaches the maximum again. Okay, so this is another way that you could visualize it, that it repeats itself every 2 pi radian. Okay. So there's a repetition that's occurring in the wave, and it does this over and over again in the positive as well as in the negative direction. I can go from the minimum here to this minimum, and that's also 2 pi radian. I'm not going to draw that line in there because it's going to get way too cluttered. Okay. We use a different color here because that always makes things a little bit more interesting. So let's look at what happens for the max and the min. Okay, so let's look at all of the max values. Well, the max is 1. Okay? And the smallest value that we can have here is negative 1. So this has a max at, yep.
Sorry.
Okay, so all of the max values are at 1. All of the minimum values are at negative 1. Okay. And these are just the vertical distances. We haven't talked about how often this occurs. And let's just see here. Let's look at the max value. This is as far as the extrema, this is pi over 2, 1. This one right here is 5 pi over 2, 1. Okay. And let's look at the minimum values. This here is 3 pi over 2, negative 1. And this here is negative pi over 2, negative 1. And if we were to continue this, you can see that there is going to be a pattern that emerges, that it's just all the max values are going to be occurring at pi over 2, 5 pi over 2, and then we're just going to keep on adding 4 to the top here. So the next one is going to occur at 9 pi over 2, 13 pi over 2, and so on. Okay, so we can write up here that all of the maximum values or maximum points occur at pi over 2, 5 pi over 2, 9 pi over 2, 13 pi over 2, and so on. All of the minimum points occur at, I should write this out clearly, maximum points occur at, all of the minimum points occur here at 3 pi over 2. And the next one, we can just keep, again, adding 4 to this, 7 pi over 2, 11 pi over 2, 15 pi over 2, the other end, negative pi over 2, and so on. So this is just increasing by, the denominators are increasing by 4. These are also increasing by 4, but they're offset. Okay, so these 4 will never align to these 4, or to the maximum numbers never align up with the minimum numbers. And one more thing that we should pay attention to here is where the zeros occur. So the zeros occur at 0, pi, 2 pi, negative pi, and you can see if we go up to this point here, this is 3 pi. So we can see that the zeros occur at pi, 2 pi, 3 pi, and we can say this shortly as any multiple of pi. Okay. Which corresponds quite well to the unit circle. We always want to kind of think back and be able to tie this back to the unit circle, that the zeros for sine occur at this point, that's 0. At this point, that's pi. And then back around here again, that's 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. So at multiples of pi. Now if you look at all of the maximum values, this are occurring at pi over 2, 5 pi over 2. So this is pi over 2, where the sine is the greatest. And you go all the way around the circle, back again, that's 5 pi over 2. Back around again, that's 9 pi over 2. The minimum values, or negative 1, are occurring at this point here. So this is 3 pi over 2, and you go all the way around the circle. Back here, that's 7 pi over 2. So this is just, all of these numbers are just increasing by 2 pi. Okay. And I'm going to end this video here, and we're going to pick this up at another video where we talk about the characteristics of the cosine function.